Hello again, everyone. So, this lesson, we're going to talk about something called stoichiometry. It's a weird word, but a pretty simple concept. So, let's get out our notebooks, turn to a clean piece of paper, and get out your packets too, because you're going to need those. So, what is stoichiometry? Stoichiometry is the quantitative relationship between the amount of reactants used and the amount of products formed in a chemical reaction. So that's stoichiometry. So take a second and jot that down, and we'll talk about it. So what are we looking at here? We're dealing with the relationship between the reactants and the products, right? The amount of reactants used and the amount of products formed. So quantitative, that means a quantity, an amount, one, two, three, four. So how much reactant is used is related to how much product is formed, right? You can only make as much product as the amount of reactants that you have available, right? So stoichion is a Greek word that means elements. Metry always means to measure. So we can kind of literally translate that as measuring elements, or we're counting atoms, right? What goes in must come out. Conservation of matter that we talked about in the beginning of the year, all right? So remember, we have reactants, right? We've said the reactants form the products, right? So reactants on the left, products on the right. So what goes in must come out, and everything is proportional. All right. So I like to think of it as a recipe like this, right? If I want to make pancakes, right? Here's my recipe. I need 3 eggs and 2 cups of flour, and that's going to make 4 pancakes. All right. Now my recipe calls for 4 pancakes. If I say, hey, I'm having a friend over, so I want to make 8 pancakes, right? Then I just got to double my ingredients. I'm going to need 6 eggs and 2 cups of flour, right? So if I say, hey, I'm not really that hungry, but I want some pancakes, I'm just going to make 2 pancakes, all right? Then I would only need 1 cup of flour and then 1.5 eggs, right? Only need 1.5 eggs. So uh, that's stoichiometry, right? It's the proportional relationship between all of the products and reactants in the equation, right? So we could think about it like this as ingredients. So let's say I open up my refrigerator and I only have 1 egg, right? And I want to say, all right, how many pancakes can I make with 1 egg? I have a ton of flour. So the flour is not the problem, but I only have 1 egg, right? So if it's a little bit more complicated than doubling and halving, then we got to do a little bit of math, but it's really not that hard, right? So what I like to do is I like to put my new amount right over my old amount. So if I want to make one, if I only have 1 egg instead of three, all right, how many pancakes can I make? That's my unknown, my X, right? So I don't care about flour right now. I have an unlimited amount of flour. But if I only have 1 egg, how many pancakes can I make? So then I pull that proportion out. 1 over 3 equals X over 4. And I cross multiply, right? 3X equals 4. Divide both sides by the 3 to get X all alone. And we get X equals 1.33, right? 1 1/3, right? So 1.33 repeating. So I can only make 1 1/3 pancakes, right? So that's our proportions, right? If I only have 1 egg, that's the most pancakes I can make based on the recipe that I have here, okay? So you're always given the formula, the recipe. You just got to figure out if you change something, how does that affect everything else in the reaction, all right? So let's look at an example here. 2 mg plus oxygen makes 2 MgO, all right? So we've got 2 mg plus oxygen makes 2 MgO. So how many moles of oxygen are needed to produce 3 moles of MO, magnesium oxide, right? So how many moles of oxygen are needed to make 3 moles of MgO? So I only care about oxygen and MgO. So I like to underline them. So I know, okay, here's who I'm talking about. I don't care about magnesium right now. All I care about is oxygen and MgO, right? So how many moles of O2 do I need if I want to make 3 moles of MgO? All right. So remember, nothing means 1. So there's really a 1 in front of oxygen right now. So how many? That's my unknown. So I put my X over my original amount, 1 mole of oxygen, is needed to make 3 moles of MgO. So if I want to make 3 moles instead of 2. So you put your new amount over your original amount in the equation. So how much oxygen if I want to make 3 moles of MgO? So then I pull it out. X over 1 equals 3 over 2. I cross multiply. 2x equals 3. Divide by 2, divide by 2, and x equals 1.5 moles of oxygen, right? So be specific. Don't forget your units and who are you talking about. That's proportions. That's it. That's stoichiometry, right? So not too complicated. So let's look at another problem here, and then we'll do some practice. So copy this one down. All right, so I have 4 moles of aluminum and 3 moles of oxygen makes 2 moles of aluminum oxide. That's my formula, my recipe, right? You always have that. And then you're going to get asked about changing something and how it affects something else, right? So how many moles of oxygen are needed to react with 10 moles of aluminum? So all I care about is oxygen and aluminum, right? So oxygen and aluminum. I don't care about aluminum oxide right now, Al2O3, right? So now let's change our amounts right in the equation. Make the changes right in the equation. So how many moles of oxygen, that's my unknown, are needed to react with 10 moles of aluminum, right? So if I have 10 moles of aluminum instead of 4, how much oxygen do I need instead of 3 moles, right? So now I pull that out. 10 over 4 equals x over 3. And I cross multiply. 4x equals 30, right? 3 times 10 is 30. Divide out my 4. And I get x equals 30 divided by 4 is 7.5 moles of oxygen. Again, O2. All right. So pretty simple. So if you change the amounts of reactants or products, how does that affect something else? So it's only going to ask you about 2 things. If you change one thing, how does it affect something else? Whether they're both on the reactant side or both on the product side, it doesn't matter. Or one's on the reactant, one's on the product. Makes no difference, right? That's it. So you're always going to have the equation, and then they're going to say, okay, if you change something, how does that affect something else? So focus in on the 2 things that are changing. Set up your proportion right in the equation, pull it out, cross multiply, and you're done. All right. So now let's go to page 8 of our packet and try these out. So remember, nothing means 1. So we're starting off with 1 mole of hydrogen and 1 mole of chlorine. So calculate the number of moles of hydrogen chloride. This is HCl, so make sure you're picking the right substances, right? Produced from 10 moles of hydrogen, all right? So what is this saying? If I have 10 moles of hydrogen, how many moles of hydrogen chloride are going to be formed instead of 2 moles, right? 1 mole is going to produce 2 moles. So if I have 10 moles, how much will it make? Now, some of this, the math is easy. You could do it in your head, but stick to the process so that when it's harder, you'll do the right thing, right? So 10 over 1 equals x over 2. Cross multiply, we get x equals 20. That's our answer, right? 20 moles of HCl, right? So why don't you try the other ones out on your own? So pause the video and then unpause it and we'll go over it. All right, so let's go through these. So number 2, how many moles of chlorine are needed to form 14 moles of iron 3 chloride? So again, focus in on the 2 substances that we're referring to. So in this case, we only care about chlorine and iron 3 chloride. So I don't care about iron here. So how many moles of chlorine, that's my X, are needed to form 14 moles of iron 3 chloride instead of 2, right? So we've got X over 3 equals 14 over 2. We cross multiply. I'll come up here. We get 2x equals 3 times 14, right? Oof, sorry. So we cross multiply, do our math, and we end up with x equals 21 moles of chlorine, Cl2. All right, next one. Number 3, how many moles of oxygen are produced from 12 moles of potassium chlorate? All right, so who do we care about here? Oxygen and potassium chlorate. This is potassium chlorate, polyatomic 8 chlorate, ClO3. This KCl is potassium chloride. So make sure you're looking at the right substances. But if you screwed up, you get lucky, you'll get the right answer because they're the same numbers. But just be careful of that. So how many moles of oxygen, that's our X, are produced from 12 moles of potassium chlorate? So we've got 12 over 2 equals x over 3. Cross multiply, do the math, and you get x equals, what does that come out to? X equals 18 moles of oxygen. All right. Now the last one, don't get confused by this one because it's a big long equation, because we don't care about everybody in the equation. We only care about 2 things. So if 6 moles of water, H2O, are produced, how many moles of copper are used up? Here's copper. So all I care about is water and copper. I don't care about any of these other guys in here, right? All I care about is water and copper. So if I'm making 6 moles of water, how many moles of copper are needed, right? So x over 3 equals 6 over 4. Cross multiply, and you get x equals 4.5 moles of copper. All right, not too bad. All right, so that's stoichiometry. Pretty simple. You always get the equation. That's your recipe. Uh-oh. So that's stoichiometry. You always get the equation. That's your recipe. And they'll ask you about if you change one thing, how does that affect something else? Okay, so just think about it. What goes in must come out. And if you change the amounts, that's going to change everything else, right? And that's it, right? Pretty simple stuff. Weird name, easy concept. This is how you do it. And that is all. See you all next time.